Solving, graphing, and analyzing quadratic functions. So we're going to look at this function, f of x equals 2x squared plus minus 4x plus 6, and solve it in the variety of methods we've learned this chapter. Alright, first one we learned was with the graphing, but let's go ahead and start with the first way that we learned to solve it. So to solve this quadratic function, we first started by factoring it. So if I factored this, 0 equals 2x squared minus 4x minus 6. And again, we set it equal to 0 because that is where it will cross the x-axis when y is 0. Okay, so now for factoring, notice that we can take a 2 out of all these. So we're going to pull a 2 out. So we'd be left with x squared minus 2x minus 3. And then we can divide both sides by 2 to get x squared minus 2x minus 3. From there we can factor. So we can break up the x squared, x and x. We can break up the 3, 3 and 1. We want the inside to be the minus, negative 3, and the outside to be the plus, so that together these two, negative 3x and 1x, will get me the negative 2x. Okay, from there, we're going to set each of those factors equal to 0. So x equals 3. And negative 1. So to your graph, those are telling us that the graph is going to cross at 3 on the x-axis and negative 1. Alright, let's do this same equation, but solve it by using the quadratic formula. Alright, so we're going to go x equals, so negative b, so b is negative 4, so negative 4 would just be 4 plus or minus the square root of negative 4 squared, which is positive 16, minus 4 times a times c, all over 2 times a. So it's going to end up being 16, and then we've got 12 times 4 would be 48 plus 48. We could have used the numbers where we had already taken the 2 out also. That would have kept our numbers a little bit smaller, but this way works fine. Alright, 48 and 16 would be 64. And then we can take the square root of 64 to just get 8. So we get 4 plus or minus 8 all over 4. And then we can split that up. So one of them, x equals 4 plus 8 divided by 4, or x equals 4 minus 8 divided by 4. So then if I calculate that, I'm going to get x equals 3 and negative 1. And notice that you got the exact same answers as we did for factoring. So those two will give you the same answer, it's just a different way to solve it. Alright, solve by completing the square. That's the one that we skipped this year. It is in 4.4. So again, we skipped that method. You will work with completing the square in pre-calculus. Alright, let's kind of go down our graphic organizer here over to the discriminant. So how many real zeros were there? We can see that there's 2, but how did that discriminant help us? So remember, the discriminant is the part under the radical. So b squared minus 4ac. So negative 4 squared, I'm just going to write 4 squared, minus 4 times a times c. So that was that. 16 plus 48, which is 64. that told us that there were 2 real zeros. Remember, if that number is greater than 0, there's 2. If it equals 0, there's exactly 1. If that number is a negative under the radical, that's where you're going to get those imaginary solutions. Okay, on to the graph part of it, what we did earlier in the chapter. Would this be concave up or concave down? So since that 2 was positive, we say it's concave up, it's opening up. Axis of symmetry, that's where we go, the x equals negative b over 2a. So x equals negative b, so 4 over 2 times 2. So x equals 1. So your vertex coordinate would be 1, comma, and we got to figure out what the y is. So plug that 1 value in. So our function was 2 times 1 squared minus 4 times 1 minus 6. So we end up getting 2 minus 4 minus 6 would be negative 8. Okay, our vertex, since it's concave up, it's going to go like this. Has a minimum. And then what would the minimum be? Negative 8. Okay, the y-intercept, remember, is that last number in the equation. So negative 6. So we could say 0, negative 6. This one has 2 zeros. And again, our zeros were negative 1 and 3. So let's go ahead and finish this graph here. So our starting point, our vertex was 1, negative 8. And then it was vertical stretch of 2. So normally on the parent function, if it was just x squared, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. But I want to double all of these because I had a 2 in front. So 1 over 1, 1 squared is 1, but we need to double it, so it's going to be at 2. So 2 squared is 4, double it, and now we're at 8. 3 squared is 9, we're going to double it, and we'll be at 18. Right at the top there. And then just do the mirror image on the other side. Whoops. And then we can connect the dots. Okay, finally, just putting this again together with the zeros and the graph, what would the domain and range be? Domain for these, what can we plug in for x? We can always plug in anything in the quadratics. So we're going to say all real numbers. And then the range, what would the range be? So what can y be? So we say y needs to be greater than or equal to negative 8. Okay, let me zoom out a little bit. So this is kind of the whole summary of chapter 4. The only thing that we skipped was completing the square. Okay, but this kind of summarized the whole chapter 4. So if you could do all this without needing any notes or anything, that is my goal, I guess. That's my goal for you all. Okay? All right, so go ahead and flip it over, do the backside, and see if you can complete everything. All right, talk to you later.